In this video, we're going to be finding the height of a projectile. I'm going to use an example to help us do it. So we have that a projectile is fired straight upward from the ground level with an initial velocity of 384 feet per second. During what time period will the height of the projectile reach 2,000 feet? Well, we're going to go ahead and we're going to use the position equation to help us figure out this problem. So our position equation is S equals negative 16t squared plus v naught times t plus s naught, where s is our height in feet, t is our time in seconds, v naught is our initial velocity, and s naught is our initial position. So let's go through our problem again, and let's see if we can figure out what things it has given us. So we see first we have an initial velocity of 384 feet, so that kind of sticks out, 384 feet. We see that we were initially fired straight upward from the ground level, so our initial position will be 0 feet. It says what time period will the height of the projectile exceed 2,000 feet? And so it's asking us to exceed 2,000 feet, so we want to be larger than 2,000 feet. And it's asking us what our time will be. So t is what we don't know. So let's go ahead and let's plug in all of the things that we do know. So we're going to have a negative 16t squared plus 384, and it's a plus because we're going up. And then we've got our initial height of plus 0. And we need to know, when is that greater than 2,000 feet? And we're looking for our time interval. So what is our t value? So let's go ahead and rewrite this without our plus 0, because we don't really write those, right? So negative 16 t squared plus 384 is greater than 2,000. So we're going to go ahead and begin by dividing everything by negative 16. Let's get rid of that. It can be a little intimidating sometimes to see that. And that's going to give us a t squared minus 24t is greater than, oh, but wait, we divided by a negative, so less than negative 125. From here, we're going to go ahead and write this equation in general form. So we're going to add the 125 back over, which leaves us with t squared minus 24t plus 125, which is less than 0. So we just moved that over, less than 0. And we're going to go ahead and we're going to use the quadratic equation here. So we're going to have an a value of 1, a b value of negative 24, and a c value of 125. And we're going to plug that in. So x equals negative b plus or minus the square root of b squared minus 4a times c all over 2 times a. And we can go ahead and just clean this up a little bit so that we see x equals 24 plus or minus the square root of 76 all over 2. And we're going to go ahead and we're going to plug this into the calculator because that's kind of a time saver. And that will give us 2 answers. It will give us 1 answer for using the plus sign, and it will give us 1 answer for using the minus sign. All right, so let's go ahead, let's scoot this over for a minute. Let's pull up our calculator and let's plug that in. So here we're going to have a fraction. Oops, that's not a fraction. Let's try that again. There we go. 24 plus the square root of 76 all over 2. And we'll hit plus, and we see that we get an answer of 16.35889894. Now we can go ahead and we can round that to 2 decimal spots. So 16.36. So 16.36 approximately. And then we can do it again. And so we'll do a shortcut, and I'm going to hit second, enter. And then I'm just going to arrow back to my plus sign and change it to a minus sign and hit enter. And I'm going to get 7.64 when I round that. So 7.64. So approximately 7.64. And so these are going to be my key values that I'm going to test. So my key numbers are going to be x is approximately 16.36 and x is approximately 7.64. So we'll have the intervals negative infinity to 7.64, 7.64 to 16.36, and then 16.36 to infinity. And we can do a little test here using 0 and 8 and 20. Let's go ahead and use the number 10. Let's make this easy on ourselves. So we're going to take that, we're going to plug it into our equation, and the equation that we're plugging that into is this one right here. We're going to plug that into there, and we see that when we plug in a 0, we get the value 125. When we plug in the value 10, we get a negative 15. And when we plug in the value 20, we get a positive 45. So here we have a positive and a positive down here, and then a negative here. Now I know that we were looking for when the projectile would exceed 2,000 feet, but there's something that we have to remember. We have to remember that the inequality symbol that we were given for that portion was a less than because we divided by the negative, so it had to switch. So our answer is going to be where we see the negative. That might seem a little bit backwards, but when we graph it, right, when we graph it, let's try this again. So we'll use our original equation, the negative 16x squared plus 385, and then we're going to use our 2,000 for our limit. So when we graph that, we see that the section that we want that is positive or above our 2,000 line is this little section right here. And that's going to be from 7.64 to 16.36. And so that's how we're able to say that that's what our interval is, and that's what our solution is. And so we're able to say that the height of a projectile will exceed 2,000 feet when t is between 7.64 and 16.36, which is to say that the time interval of 7.64 to 16.36 seconds is when that will occur.